Welcome into my party, people. The recording started. My name is Coach Anderson, and welcome to our class on distance, rate, and time. So, in today's class, we're going to be going over three main things. Number one, how to use that formula. We're going to look at the formula, distance equals rate times time. Cool. That's the basics of the basics. Number two, we're going to learn how to translate the English that we see in word problems into that formula the right way, which, again, that's a pretty fundamental piece. But number three, this is where things are going to get pretty interesting. So before I get started on what I'm about to spiel for number three, who here has ever dealt with a problem successfully or unsuccessfully, or even been nervous? Who here has dealt with a rate problem that had more than one rate, or more than one time given to you, or more than one distance given to you? Who here has dealt with a problem with multiple of the same type of unit? Quite a few of us. Quite a few of us. And how have you felt then? Let me follow up on that. How have you felt when you're doing a problem like that, that particularly in the moment, you may not have been ready for it? Stuck, confused. How else did we feel? And with, got your message. Thank you. You felt lost, didn't know what direction to go in, dazed. Man, this should be a word knowledge class. How else did it make you feel? Lost, anxiety, lost. You just LOL'd and left. Okay, that's fair. That's absolutely fair. Davian said, hey, that's me too. Let's go ahead and move on. I want to tackle these. Perfect. So let's go ahead and understand that just because you have a formula doesn't mean it's always cut and dry in terms of how you're supposed to use it. So first thing we're going to do, we're going to learn the formula, and then we're going to introduce ourselves right away to practice problems and being timed, and I'm going to review with you step by step. And then after that, we're going to continue getting into more and more difficult questions. And then after the fourth, fifth question, I'm going to allow you guys to dictate where the class goes from there. So let's begin with the formula. Distance equals rate times time. I'm fairly sure that 99% of us in this class right now understand that formula. We have it committed to memory, but there are things that you may not have committed to memory because you may not have practiced as much as you need to. So first things first, let's start with understanding what the heck a distance is. So here's distance. Distance is the amount you're going to accomplish. So let's try this little exercise. I'm going to give you an example of a unit or a number or an amount, and I want you to tell me yes or no, can that be considered a distance? So everybody, let's go ahead and try this out. Let's start with 100 miles. 100 miles. Everyone, is that a distance? 100 miles. Is that a distance? Okay. Looking at the chat here, looks like everyone is saying yes, 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 YS, capital YES. Yeah, it looks like the vast majority of us are all in agreement. How about, let's say, 55 kilometers? What about 55 kilometers? Is that a distance? Okay, as expected, I'm seeing a lot of yeses flood the chat box as well. I'm really just seeing if you have a pulse right now, if you're alive. So let's go ahead and ask another question. How about, I don't know, 15 inches? 15 inches? Okay, too easy, right? The majority of us are still saying yes. Everybody's agreeing. Okay, cool. Let's switch it up. What if we had, let's say, 200 gallons? Is 200 gallons, could that be a distance? Ooh, okay. I see a lot of people here saying no. And that's where this class truly begins. So, contrary to what you might believe, yes, anything that you're trying to accomplish can be considered a distance. 100 teddy bears, that could technically be a distance if the situation is saying that you're trying to accomplish 100 teddy bears. Or 200 gallons. If you're filling up a tank with water and you're filling it up at, let's say, 20 gallons a minute. Well, then yes, that 200 gallons, that is the distance that you're trying to accomplish, or the amount that you're trying to accomplish. And so this is where I want to start just breaking down some of the things that you thought were true. And I want to explain why, so you have the confidence to move forward. So number one, distance is not just distance. Distance is anything or any amount that you're trying to accomplish, any value that you're trying to accomplish. So Yakeem, no, you are not a distance in and of yourself, not quite. But if you said, hey, I want to interview 1,000 people and I'm interviewing 10 people a week, yeah, then 1,000 people, yeah, then that would be a distance for sure. So you're getting close there. So let's talk about this. Again, the regular way to define distance, and I'm going to go ahead and just zoom out a little bit so you can see all the red here. The regular way that we define distance right over here, yeah, we talk about miles, yards, feet, kilometers, etc. We talk about all those for sure. But other things that could be considered distances, again, are weight, items, reading number of pages. So let me stop right there. Have you guys ever done a problem where it says, hey, Stacy is reading at an average rate of 40 pages an hour, and she's trying to read a total of 700 pages. How many hours of reading will it take? Has anybody ever heard of a problem like that? I see a ton of yeses, ton of yeses. And the answer to that is yes. That specifically is a distance, rate, time problem. It is. It can also be considered a solving equations, y equals mx plus b. They're interchangeable, they really are. But yes, that is a distance question. But it's not just the presence of having a distance that makes it a rate word problem. Let me say that again for those of you who didn't hear me. It's not just the presence of a distance that guarantees that it's a distance, rate, time problem. There's a different unit that guarantees it. Everyone, it's not the distance that guarantees that it's a distance, rate, time problem. Which one is it? Which one is it? The distance, the rate, or the time? Which one guarantees that you're dealing with a distance, rate, time problem? Nicole, right on. Yes, it is going to be the rate. Seeing a rate in the word problem guarantees that you're dealing with a rate word problem or distance, rate, time, because this is pretty much what connects the distance and the time together. So let's take a look over here in blue. So the rate, what you consider the rate is, it's basically the speed that you're achieving that distance. So remember earlier how I said, hey, we're trying to interview 1,000 people. That's our distance. The rate that we're interviewing at is 10 people per week. Or if we think about the gallons example that I gave earlier too, we're trying to fill this 200-gallon tank and we're filling it with 20 gallons per minute. Now in each of those examples, and in these as well, pages per minute, pounds per month if we're trying to achieve weight loss, miles per hour, dollars per hour. Everyone, can you see a pattern going on here? What's the specific key word that we see in all of these examples that give away a rate? Absolutely. The word per. The word per is what gives it away. So remember, what a rate does is it tells you how quickly you're achieving the distance. But more importantly, or more technically, we're talking about connecting the distance and time. Distance per time. Distance per time. Distance per time. Everyone, do you see the pattern that I'm pointing out here? Yes or no? Cool. Again, rate is the speed or pace that you're achieving that distance, and it's always noted as your distance per time, every single time. So hopefully, even if we're not confident at all when it comes to distance, rate, time, I'm hoping that you can see this fundamental fact and we can write that down with confidence, knowing that we can identify it later on, and we'll get plenty of practice. But lastly, talking about time, time is just how long it takes to achieve that distance. I don't think that needs to be stated more than it's written down right there. I think we can identify time, milliseconds, seconds, minutes, hours, days, weeks, however long. So there we have that. I'm going to zoom out just a little bit. And I would love for you guys to take a screenshot if you could. I'll go ahead and zoom in just a little more there. Take a screenshot if you need to, but we're going to move forward from the slide in just about 10 seconds. And I'll answer some questions here that I see. So Diego, exactly. Yes. The answer to that is yes. When it comes to the ASVAB, unless there is like 99.99% of the time, unless they are trying to, give you something else or make it about something else, if you see the word per, you're going to be in some way, shape, or form applying the distance, rate, time formula. So yes, if you see the word per in there, at some point you'll be applying the rate formula for sure. Cool. So if you're ready, everybody, if you have what you need written down, just type ready in the chat box and we'll move forward from there. Sounds good. Cool. Oh man, this is going to be a fun class today. So here we go, my party people. Here's my party people. Here we go. So number 2, the real key here is to be consistent. Okay. I definitely want to take a quick moment to just explain what this means, because too often, a lot of us get a little too overconfident. That's the word I'll use. Sometimes we get a little too overconfident because we know the formula and we think that's all we need. But formulas, like all math ideas, follow specific rules. So follow along with me here. When it comes to this formula and all formulas, it's about being consistent and representing the formula the same way. So for example, let's go ahead and say we're talking about a situation with Bethany, and we're looking for Bethany's time in this situation. Well, if we're looking for Bethany's time to accomplish something, well, we need the distance that Bethany is trying to accomplish, and we need the rate that Bethany herself is accomplishing this task at. Not Joe, not Brandon, not Devin, not the other Anderson that's in this class, even though you're probably the best Anderson out of all of us. But with that, let's see if that makes any sort of sense to y'all. Being consistent. Yes or no, tell me in the chat box. Representation matters when it comes to math. Nice. Cool. And I'll give it a second to get all the replies. Looks like about half of y'all already flooded it in. Excellent, excellent, excellent. All right. So next up, just another example here. So this is a very common type of example as well, too. So if you're looking for the time for an entire trip, well, then remember, you need to use the distance for the entire trip. And you also need to use the average rate for the entire trip. You cannot say, oh, if I'm looking for the time for the entire trip, I can use the distance for the first stop and then the rate for the rest of the trip. No, it doesn't work that way. If it's you need to represent the same thing. Just like with proportions, just like with everything else in math, you need to be consistent. And we're going to show some examples, or have you go through some examples of what that truly means. So with that, I am done giving notes, because now from here forward, it's time to show and see where you currently stand. And then when it comes to my guidance after the problem and the time is over, I'll be guiding you through step by step every single question. That way we can grow from those mistakes and then challenge the next question right after that. So with that, let's go ahead here and give you guys an appropriate amount of time for this first question. Typically, I'm going to give you anywhere between 2 and 3 minutes per question. If I believe that this is a question that's a little more fundamental, hey, 2 minutes. And then if it's something that's definitely a little harder, I'll go ahead and give you the 3 minutes. And I'm going to do that so we can keep a good pace throughout the class. I'm not going to assume that any of you know how to do any questions. I'm just simply changing the time frame so that way we can move forward in time. So let me get this timer going. There it is. And this first question, everybody, is going to be 2 minutes. There's your timer right there. And so just remember, when you're ready and you have an answer, just type ready in the chat box. And if you're confused, try your best. At the end of the timer, take a guess if you need to, but don't give up. Be engaged every bit of the way, learn from those mistakes, and let's ace the ASVAB. Question number 1, let's go. Timer started. "25 seconds left. You guys got this. Keep up the great work." And 2, 1, and time. Put those answers in, put those answers in. And if it's a guess, go ahead and put a question mark next to your answer. But we might be able to expect that a question like this might be a little more common than the other ones that we might see later on. But it's fine. We're going to be tackling this just the same. So, with every question, we want to start off with identifying the goal. What's the purpose of this question? And we always look to the question sentence to figure that out. So, we're going to dive on in. We're not going to waste any time. We're going to make sure we do this the right way. So, right here it says, how long was the car traveling for? My party people, what's a key phrase that we're really going to just underline? In that red highlight, how long was the car traveling for? What is it that we are going to underline? Shout out to Landa. Welcome in, Landa. Congratulations again. You weren't here earlier. I gave you a massive, like, 2-minute shout out because I heard that you passed last week. So thanks for not showing up to that, but also congratulations. Hey, you know, I love you. You have been an amazing student to have, Landa. Thanks for coming in and stopping by and saying hi. Yeah. So, that's all good, Landa. But getting back into things here, yeah, we're looking at the part that says how long. Now, how long could mean a distance. It could mean a time because you might say, "Hey, how long is the street?" Or you could say, "How long is it until we wake up?" So that might seem a little tricky. Like, what is it that we're looking for? Everyone, quick question. When we're not sure what the answer is supposed to be in terms of the unit, where might we be able to look? Yeah, Fiona, exactly. We can look at the answers. We can look at the answers. If we look at the answers right over here, 9.5 hours, 11.5 hours, 12 hours, 11 hours. Everyone, which one is it that we're looking for? A distance, a rate, or a time? Exactly. So again, just a calm, cool, and collected way to approach it. We're looking for time. Blank hours is what we're looking for. And so again, in your mind, in your head, you can just say that that's a time period. Let's look at the information we're given. Information we're given, that's step 2. After we know what we want, go to the information. And what we have is right here. A car is traveling at an average speed of 70 miles per hour. And then we see that it says eventually travels 770 miles. So I hope that we can see that, hey, we have all the information we need to knock this problem out of the park. We see that we have our rate given to us. miles per hour. And everybody, pop quiz. How do we know that that's a rate again? How do we know? How can we guarantee that this is a rate? Exactly. The word per, you guys are on it today. I love it. Yes, the word per is what alerts us that's a rate. So, boom, we can guarantee that. No question about it. And then lastly, we see over here that we have 770 miles. And we know good and well that that is a distance measure. So, gathering the information, depending on how much experience you have, could be easy, could be hard, but I want to make sure that you can get better from wherever you are. We have that. Now, the last step here, we're going to set this bad boy up, solve, and we're good. Everyone, let's replace it together here. Help me out. We have D equals R times T. What are we putting in for the distance? Help me out. Quick in the chat box. That's right, 770, right there, nice and easy. Then what are we putting in for the rate? That's right, nice and easy. And what are we putting in for time? Trick question, that's what we're looking for. Yeah, we'll just put T. So there we go, we have that. And so the last step that we need to take is solve this equation. Now I'm going to pause right here because I know a lot of people want to ask, hey coach, how do I know when I'm supposed to be multiplying or when I'm supposed to be dividing? Very common question that we get when it comes to DRT problems or solving equations in general. When you take a look here, everybody, just ask yourself, is what we're looking for, the time, is the time already by itself? Is the time already by itself? No, it's not. It's covered with a 70. It's 70 times t. The t is not by itself. If the t was by itself, then we just do whatever it is on the other side and we're done. But it's not by itself yet. We need to perform or do work to get it by itself. And that's where we have to ask ourselves, what do we do to get rid of times 70? Well, opposite operations. That's how we solve equations. We do the opposite operation to get that variable by itself. So here, we'll divide both sides by 70, and we're good. Once we do that, well, on the right side, on the right side, we will go ahead and cancel out. And on the left side, we'll have 770 divided by 70. So we can cancel out those zeros. 77 divided by 7, everybody, is what? Thank you. It'll be 11 hours, Fiona. Appreciate that. And we are good. And boom, we're good. So even for those of us that were a little apprehensive about a question like this, do we feel like we are potentially getting the hang of just understanding how to set things up? All right, good. So with that, I want to go ahead and take us straight through the next question. I want to take us straight to the next one. The advantage that you have is that you know that this is a distance, rate, time problem. You know that. So I want to see what you do about this next one here. Boom. Here we go. I'll start the timer again. I will give you 2.5 minutes for this one, and you'll get started right now. Let's have some fun, guys. So let me start the timer in the background. So just assume the timer's already started. And I'm going to disappear in 3, 2, and get to work. 3, 2, and 1. Go ahead, plug those answers in, and at the same time, go ahead and put a question mark next to your response if you feel like you might be taking a guess. Go ahead. All right, okay, I see y'all. Okay, put those answers in. Again, don't be shy. Put a question mark if it is a guess, because at the end of the day, we want to make sure we have a chance to improve from where we are. So if we're not honest about where we are, it's a little harder to be in a position to continue making progress. So with that, let's go ahead and tackle this one. Okay, cool. So I see a lot of people saying C, no problem at all. Let's have some fun. All right. So let's see here. Two trains begin from the same position and travel in the same direction. Everyone, what am I doing wrong? What am I doing wrong already? What am I doing wrong? That's right, Nicole. We have to read the question first. We want to know what the goal of the question is before we start doing mental gymnastics, wondering, what are these two trains doing? Same direction, same position. What does that mean? Are they both going up, both going down, side to side? I don't know. Loop-de-loop, pull them tight. I don't know. We need to make sure we understand the purpose of this all before we start trying to guess or assume what's actually going on. So, read the question here, right over here. How far apart will the trains be after 3.5 hours? My party people, what are we looking for? Are we looking for a distance, a rate, or a time here? Yakeem, no worries. I've been doing this for a while, so I can take a guess as to what might be going through your heads. So, yeah, we're definitely looking for a distance here. And to support that, let's see right here. How far apart? That's a nice key phrase. How far apart? How far apart are A and B, or these two things? That's definitely a distance. You can feel that. You can read that and feel that. And if you weren't quite sure, you can read the answer choices and you can see that miles by itself, absolutely a distance. So we can say for sure, yeah, we're looking for a distance. Distance equals blank. So far, so good. Now, step 2. We need to look at the information that we have, because this is where things might get just a little confusing. This is where things might start being turned upside the head, because when we looked at the distance, rate, time formula, and I'm going to write it out here just for reference, we may be assuming that, hey, we have one distance, we have one rate, and we have one time. What do we do when we have more than one? Let's see. So, reading through the information, we see that two trains begin from the same position and travel in the same direction. So I'll go ahead and illustrate right over here, because you guys all know that I am the world's best artist. So take a look over here. I'm going to draw two trains. Okay, so we're going to go ahead and draw train number 1. Again, world's best artist. And then because I'm so great, boom, there's train number 2. So there we have them. And we're going to go ahead and call this one number 1. And this one over here, number 2. And everyone, what did we say the trains are going in what direction again? The trains are going in what direction? Yeah, they're going in the same direction. Let's read that again. Let's make sure we got that down correctly, right? Travel in the same direction, right there. Same direction. So because we know that these trains, again, will be traveling in the same direction, nice and easy. So I'll just go ahead and put one arrow here and another arrow here. And I'm going to leave that there for now. That graphic is going to be very important in just a few moments to help us visualize what's actually going on, and it's going to tell us what we actually need to do. But until then, let's make sure we can get there pretty clearly. So back to the information. Train A, right over here. Train A and train B travel at 40 miles per hour and 68 miles per hour, respectively. That just means that, hey, look, first train, 40 miles an hour, second train, 68 miles an hour. So let's go ahead and go down here. And because I reserved the bigger arrow for the top one, I'll just go ahead and say that that one's 68 miles per hour. And then the second train, was 40 miles an hour. And again, it doesn't matter which one's which. It really doesn't matter. As long as you would take account for both of them, you're good. The way you draw it out doesn't really matter. So here we have it. Everybody, are we in accordance right now? Are we cool so far? Again, that perfectly drawn train up top, that's the train going 68 miles an hour. The perfectly drawn train on the bottom, that one's going 40 miles an hour. And since they're both going in the same direction, that's why you have this arrow and this arrow going in the same direction. So yes or no? Are we good? I see a ton of yeses so far, but are we good? Cool. Thanks, Michael. All right, cool. Excelente. So with that, let's keep processing the information. We got this part taken care of. So let's use a highlighter here just to note that we got that out of the way. We got that, and we got that. And now we're asking again, how far apart will the trains be after 3.5 hours? So they actually gave us the time that we should be writing down as well. So we have a time here equal to 3.5 hours. So before I continue, what's the problem? Given everything we know, let's pretend that this is a blank slate for us. This is our first time doing distance rate time. What's the problem? We're looking for distance. We have a time. But what about the rate? What's the problem with the rate? You guys tell me. Right, we don't have a solid rate yet. We don't have one singular rate that represents this scenario. Because again, these trains are moving at the same time from the same position. So there can only be one rate that represents how far apart they're becoming. Let's figure that out. My party people, let's go down here. And let's make this example, let's make it a lot simpler. Why do we have to deal with 68 and 40? Let's deal with something easier. Let's go ahead and say, instead of 68 up top, let's pretend that this one was, let's say, 10 miles an hour. And let's scratch that out of the way. Let's say that one's something smaller. Let's go ahead and say that that's 3 miles per hour. So I'm going to play off of your common understanding. Everyone, if that train up top is going 10 miles per hour, after 1 hour, how far does it go? Again, 10 miles per hour. After 1 hour, how far will that train go? Evelyn, appreciate you. Yeah, after 1 hour, 10 miles an hour. After 1 hour, 10 miles. Another hour, 10 miles. Every hour is 10 miles. So after 1 hour, 10 miles. Now, let's look at the second train. That one's going 3 miles per hour. Again, 3 miles every hour. So after 1 hour, how many miles? Help me out. Yeah, that's going to be 3. So my party people, here's where the logic comes in. Here's where our thinking caps come on. After 1 hour, we said, hey, this first train, this one goes 10 miles. This second train goes 3 miles. So with that said, everyone, what's the gap at that point? After 1 hour, how far apart are they? How far apart are they? 7. Again, we're using simpler numbers in a simpler situation, but the logic stays true. It's going to be 7 miles of a difference. So again, if they're going in the same direction, if one train is traveling faster than the other, well then, if we're trying to see how far apart they are, well, we got to take away what they've both already covered. We have to take away or subtract or cancel the distance that they both covered and only worry about the gap. So here's what I'm saying, everyone. If you're talking about a rate word problem where you have these objects going in the same direction, you are going to subtract their rates. You'll also subtract their distances if you're trying to see how far apart they are, because that's exactly what we did. So that's the idea here. If we have 2 rates and they're going in the same direction at the same time, then that will be, hey, subtract those rates, to get the true rate. So let me write that down right here up top. Same direction. Equals subtract the rates. Everyone, yes or no? Does that make any sort of logical sense in your head? What we're going to be doing with the rates is subtract them because, again, if we're going in the same direction, well, they're partly covering the same distance. So we need to see not the same distance, but the gap between them, canceling what they've both already covered. Because if they both take one step at a time, they're not apart. They're still zero. But if one goes more than the other, we take away what they've both already covered to get the gap. And so in this situation, sounds good, Diego. So in this situation, here we will subtract the rates. What were the true rates again? Well, it was not 10 and 3, but it was over here. Let me use an eraser, a proper one. It was 68 and 40. So everyone, our true rate would be 68 miles per hour minus 40 miles per hour. And that's going to give us what, everyone? 68 minus 40 will be 28 miles per hour. And so therefore, that is our true rate. Our rate, again, is 28 miles per hour because we are subtracting them because they're going in the same direction. If they're going in opposite directions, well, we would add the rates because think about it like this. Both of my hands start in the same position. My first hand here takes one step this way. My second hand takes 2 steps this way. So again, 1 step this way, 2 steps that way. What's the distance apart? What's the distance apart? Here, it's going to be 3. Because if we start in the same position and go opposite directions, 1, 2, 3. And so I hope you can see, naturally speaking, what you would do with those in that situation. So again, opposite directions, we add, same direction, we subtract. Our rate is 28 miles per hour. And we have a very simple question now. When we fill in what we have, we're good to go. We're looking for the distance. My rate is 28 miles per hour. My time is 3.5. And all we have to do is complete that operation, and we're good. Let's go ahead and get it done. Zoom on in over here, perform some mathematics. 28 times 3.5. So then we have 8 times 5, which is going to give us 40. 2 times 5 is going to give us 10. Carry that, 4 is 14. Then we go over to the next line here, next place value. So now we're covering the 3. 8 multiplied by 3, that's going to give us 24. 2 multiplied by 3 gives us 6. Carry that 2. That's going to give us 8. We add this together. We'll have 0, 8, and 9. And as a reminder, my party people, what do we do with that decimal here at the end? We had 1 decimal place total there, and we'll bring it back. Exactly. Thanks for being sharp, Fiona, or Fione. I appreciate you there. So you have 1 back, and so we'll bring 1 back. So the total distance, 98 miles. But it's not just about the number that we have at the end. It's always about how we got there. Can we clearly explain how we got there? And in this specific instance, again, because we're traveling in the same direction, we cancel out or subtract what they've already done together because we just want the gap. But if it's opposite directions, they don't cover any of the same distance. It's one going this way, one going the other. We add those distances together. And that's why ultimately A is the correct answer. How are we feeling about this one, everybody? I know this one definitely not as easy as the previous one, but it should definitely be a little more rewarding. How are we feeling? Today makes a little more sense there. Okay, Remy feeling great about it. Fiona feeling good. Keo feeling good. Okay. Mario feeling good. Naomi, did you ask a question? Let me just make sure I don't look you over here. I didn't see a question from you, Naomi. If the question mark means you're still confused, no worry. Oh, need more practice? Gotcha. Cool. And I'm glad you can see where you make mistakes, Nicole, because it's always about growing from them. So with that, let's go ahead and dive in to this next one here. Here's another distance rate time question. I'm going to give you here on this one, I'll give you another 2.5 minutes. How about that? Timer started. Go ahead, give it your best shot. Type ready when you're ready. And remember, you know it's distance rate time, but do you know how to set this up? Two, one, and time, my party people. That is time. Go ahead, put those answers in. Put a question mark next to your answer. As always, there's no shame in taking a guess, but there is a shame in not trying at all. So go ahead, put your answers in, and let's get this going. As always, remember, we're not going to know everything there is to know. I don't know anything there is to know. Let's get that out of the way. Our egos, leave them at the door. If we are confused, well, then let's just take this with as much grace as we can and learn from those mistakes. So, everybody, my party people, let's ask ourselves the very first basic question. What is it that we're looking for? Are we looking for a distance, a rate, or a time? Which one is it? Time? Okay. Yeah, I agree. I absolutely agree. Because if we're taking a look right over here, we see that it says, hey, how long did the trip to the beach take if the return trip took 3 hours? Okay. So we are looking for how long did the trip to the beach take? Now, we're looking for time. But did anybody get confused by reading that right here? I see a time right there. Did anybody get confused and be like, yo, if we're looking for time, there it is. We're good. Did anybody hope that that would be the case? Anybody here hope that that would be the answer? And it's okay. Right? It's okay. Let's learn how to deal with this type of question. Again, the point here is to learn these different situations and understand what makes them different. In the previous question that we did, you may have noticed that we were working with a scenario, one single scenario. one single scenario with two objects moving at the same time, right? In the previous example, we had two trains that were moving at the same time. Is that the same in this question, everybody? Are we dealing with the same scenario as the previous question? Are we dealing with two things happening at the same time here? I see some no's and I see some yeses. Pretty interesting, right? It looks like we may not be as confident in that question, and that's okay. So allow me to go ahead and just kind of lead the way here and help you understand and make sense of this. So let's take a look here. Let's take a look. So number one here, what we're looking for is again, how long as in time, but pay attention here, trip to the beach. So I'm looking for, again, blank hours to the beach. And then it says over here, the return trip took 3 hours. So everybody, even though we see 3 hours, does that 3 hours represent the time to the beach? Or is that a time for something else? You tell me. Are those 3 hours here the time to the beach? Or is that something else? Yeah, exactly. No, that's the time back. That's the return trip. So here's what I'm going to do. On one hand, I'm going to highlight one scenario. How long did the trip to the beach take? That's going to be in red. To the beach is going to be in red. And in blue, I'm going to write, well, the return trip, because it's clear here that we have two different things going on. So until we figure out exactly what it is that we're supposed to do, maybe it might make sense to just organize the information in a way that might make it a little easier to read. Yes or no? Do you agree with me? Again, until we know exactly what it is we need to do, let's organize the information into some categories, because it looks like we're talking about going to the beach and then going back home. So let's organize the information accordingly, and let's hope something makes sense of it, right? So here, 3 hours back home, or I'll just say returning. And now let's read through the information. And again, keep writing down what makes sense in what category. So we're talking about our friend Ryan here. So Ryan biked to the beach and back home on the same route. Ooh. Everyone, are there any numbers in that sentence? Ryan biked to the beach and back home on the same route. Are there any numbers in that? Nope, right? I don't see any numbers. No numbers. I don't see any numbers. But there is a very important piece of information in that sentence. Everyone, think about it like this. If I, from my position right here, if I walked from here to the grocery store, and then from the grocery store, I walked back home the exact same way that I went, I came back. What is that hinting at? What is that hinting at? Ooh, who said it? Is that Naomi? Nasmus. Nasmus, the distance is the same. Everyone, let's just picture it. Just picture it. If I start from here and I go there, and then from there I go back here, is that not the same distance? Is that not the same distance? If I go from here to there and there back here, the same way that I came. That's what they're hinting at. And so we must be able to notice these very big hints when we see them. This right here means the distance is the same. Let me know if that makes sense in the chat box, yes or no. The distance is the same. Cool. I'm glad that it's starting to make sense, because like we're not out of the woods yet. That's not the only thing that matters, because that's going to help us get the work done. So the distance is the same. So what that means is if we're talking about this here, blank miles returning, these are the same. These are the same. Now, let's see where that comes into play. Because, again, as a reminder, we're looking for the hours to the beach. So we're going to need the distance to the beach and the time and the rate to the beach. If we have those pieces, then we're good to go. But as you might predict, it's not going to be that simple. So let's keep looking at the information. On the way there, again, on the way there, Ryan backed at a rate of 36 miles an hour and biked at a rate of 60 miles per hour on the way back. Let's organize that. Let's organize that with impunity. So we have here, again, on the way there, we can highlight that in red. On the way there, biked at a rate of 36 miles per hour. So right here, 36 miles per hour. And then we see on the way back, 60 miles per hour on the way back. So I'm going to write that right over here. Now, I'll ask again, is it very clear that there are two scenarios in this problem? Is it very clear now? Yeah, we have two scenarios. That is, I hope that is now proven. We have the same person, Ryan, but we're talking about two different instances. So we're not adding any rates, subtracting any rates, adding distances, subtracting. This is completely different. And I hope you can see why. Because now that we're looking at this, well, if I'm looking for the hours to the beach, the time to the beach, then this is all I care about. But everybody, what's the problem? If I'm looking for time, I'm given the rate, but what am I missing to be able to solve this? Again, I'm looking for the time. That's what I'm ultimately solving for. I have my rate. What is it that I'm missing here to actually succeed? Israel, that's right. Distance. Yakeem, that's right. Distance. I need the distance. If I don't have distance here, I can't set up my formula. I can't. So this is where we're going to use that big piece of hint or that big glaring gift that this problem gives us. Ryan went the same way to the beach as the way back. And because of that, again, that means that the distances are the same. And so what that means is if I find this distance over here, I can place that distance over there. Let's set this up and let me show you the beauty of this. Distance equals rate times time. So my distance here equals, my rate is 60 times 3 hours. Everyone, what is the distance between the beach and Ryan's house? What is it? Delilah, excellent work there. Yes, that's going to be 180 miles. 180 miles. Now, at this point, I don't want any questions as to what kind of bike Ryan is riding or if he's able to actually ride that long. That's not my concern. Shouldn't be yours either. Leave me alone. So we have 180 miles, everybody, and that's for the return trip from the beach back home. But that also means that 180 is the distance from the home to the beach. That's why we can fill that in. That's why we can fill that in. And because we filled it in, everybody, are we ready to solve the question now? Are we ready to solve this? And there it is. Now we're ready to solve this. We can absolutely solve this. Let's zoom back in over here and we're good. Our distance equals rate times time. And our distance, again, that was gifted to us, 180 equals, equals 36 miles per hour as the rate. And the time that it takes, we'll figure that out. Everyone, what do we need to do to solve this? What do we need to do to solve this? That's right, divide. We need to divide and we're all good. So here, divide both sides by 180, or excuse me, what am I doing? Divide both sides by 36. Jeez, long Monday. Divide both sides by 36 and we're good. We'll go ahead and cancel out on the right side. And I'll actually use a highlighter for that to make it a little easier to see. And they cancel out right there. And so we really just need to figure out what 180 divided by 36 is. Using some mental math, we can actually divide by 6 first on top and bottom. So if we divide by 6 first, that's going to give us what? 30 over 6. And then everybody 30 over 6 gives us, exactly, it gives us 5. And so our answer will be 5 hours to the beach. Boom. And that's going to be answer choice D. So you guys tell me, is this something that's doable to you? Is this doable? Because I saw the vast majority of us saying, man, this kicked my butt. But do we see what's going on now? Proud teacher moment right there. You guys have been doing an excellent job in today's class. We're more than halfway through, but you guys have been doing an excellent job so far. Hey, I'm glad you're getting more practice in. That's the good part about it. So we're halfway through. We have a few more new problems to tackle. But I want to remind everybody who is here for the first time or didn't hear my announcement earlier in class. For those of you who are in the program, currently live in the program, if you ever want a live progress update, you can get that at any time now. You don't have to wait for me to send out those emails on a weekly basis. You can get a progress update live right now if you want to. All you need to do is go ahead and text our automated line here, 833-321-0182. Again, if you are currently in the program, text that number and ask it for a progress report. Say, hey, what's my current progress? And I can guarantee you in a few minutes, you'll get a progress report with exactly what you need to do moving forward. It'll give you things like your completion for the math basics, AR, MK, how many stars you've achieved, what your average star rating is, and it'll even include the links to the next assignment that you are working on. This is real-time data, so if you go ahead and pass a speed drill in the program and you wait a few minutes and you text that robot, it'll confirm you have passed that assignment. So I'll leave that there for you guys. Again, one more time, if you're in the program, 833-321-0182. And if you're curious about the program and you want to try it out for free, I got your back. Let me go ahead and put this trial link in the right here in the chat box for you. So if you ever wanted to try the program out for free, there it is in the chat box. Feel free to hold on to that till the end of class. That way, you can get a free 7-day trial, no credit card required, and see for yourself why over 1,500 of my students have aced the ASVAB. So with that, let's dive on into the next question here. 3, 2, and 1. Here's another one. Try it out, my party people, and I'll let you do your best. All right, still got about 5 seconds left here. Looking at our final 3, 2, and 1, my party people. All right. Put those answers in. I see you guys getting pretty excited about handling a question that's a little unorthodox. Perfect. All right, so let's handle this. Let's really, really handle this. So remember, if you were here in the beginning of class, that distance is not only just distance. Distance is whatever it is that you're trying to accomplish. So everybody, did this question prove to you that you can have a distance rate time problem where the distance is something other than a pure distance? Do we see that in this question here? Do we see that? Because this is going to be the part, right on, Akeem. So this is going to be where things really start opening up for you, because if you start, having those blinders on and you're only looking at it as it's supposed to be only one certain way, well, then when they change things up just a little bit, you might end up being more confused than you need to be. To be honest, this is a fairly simple question. Would you guys agree? I would say that this is a fairly simple question if you understand that, hey, that 600 gallons, that's a distance. Cool. I'm glad you guys agree. I'm glad that we agree. Let's tackle this. Let's make it look easy. So what are we looking for? Well, about how long will it take for the container to completely empty? Okay, so we're looking for the time. About how long will it take for the container to completely empty? We're looking for how long it'll take till this thing drains. So if we were to draw this out, again, I have a PhD in stick figure drawing. So let's go ahead and see what this is going to look like. I have this container. I don't know how that happens. So I'm going to just say, hey, we have this. A line there. I love you guys. Thanks for maintaining this. So then we have this gallon here, this container. Cool, great. And then we have some water inside of it. Cool. And so it has an unidentified leak that it's leaking at a rate of 22 gallons per minute. So I'll say that we have, boom, right there, sweet. And let's say that we don't have any flex tape, we don't have any of that stuff. So we have the water leaking out, spilling everywhere. And that is happening at a rate of 22 gallons per minute. With a leak that big, you definitely want to take care of that for sure. But total, so yes or no, everybody, can we picture this? Can we imagine this? We have this 600 gallon container and it's slowly draining because we have a 22 gallon per minute leak. Yes or no? Does that make sense? Again, it's really good to be able to visualize these questions because it really does simplify the process for you as opposed to just taking guesses and hoping things work out. So great. Glad you guys agree. So now what we're going to do is, again, we're looking for time. We have the distance, which is 600 gallons. And then we have over here, let me just take this over here. And then we'll have a rate that is 22 gallons per minute. Now, you see that the answers are all in minutes as well. So that tells me that, hey, we're good to go because my distance and my rate and my time, they all match up. Again, my distance is in gallons, my rate is gallons per minute, and my time is minutes. So things match up. We're good. So that's it. We're going to set this up and we're done. 600 equals 22 times t right here. Solve this and we're done. I'll divide both sides by 22. So everyone, what's the first thing that we can do? Well, if you're trying to do 600 divided by 22, you could try to simplify first. So you could try to divide the top and the bottom by 2. Again, trying to do some mental math where you can. 600 divided by 2 is going to be 300. Everyone, 22 divided by 2 gives me what? 11. That's right. So now we're just trying to figure out what 300 divided by 11 is. Once we figure that out, we're good. We're in a good position. So we can either do long division here if we'd like to. You can take guesses and hope for the best. I mean, it's really up to you. But I'll just go ahead and just divide by 11 with long division. And I'll do that over here, giving myself a little more room. And I'll do it over here. 11 into 300. 11 goes into 30. That's going to be 2 times right there. And then we'll go ahead and subtract the 22. And that's going to give us 8 left over. And we'll bring down that 0, giving us 80. 11 goes into 80 7 times. And don't assume that you're done here. Do not assume that you are done, because you could have 27 and you could have 28. Don't shoot yourself in the foot here, because we have to make sure that we round to the best nearest value. Pay attention to the question here. What does it say about how long? Not exactly how long. So this tells us that we do have to round at the end to the nearest minute. Yes or no? Does that make sense, everybody? We need to round to the nearest minute, because if not, we might get confused, potentially, allegedly. Cool. Glad to see that, Nicole. So let's continue here. So 11 goes into 80, like we said, 7 times. We'll put a decimal place there. We'll bring down another 0 after we subtract that. 11 goes into 30. Everybody help me out. How many times? Yeah, just 2. So because of that, let me mark that as red. Everyone, should we round up to 28 minutes or round down to 27? Right, in this case, we would round down, and that would be 27. And that would be right there, answer choice D. So in fact, it wasn't really a big deal. We didn't have to round up to 28, no problem at all there. And for the person here asking, hey, why did we use 300 and not 600? So all I did was I made the process a little easier for myself. Instead of dealing with 2 massive numbers, 600 and 22, I said, hey, look, we can simplify that real quick before we do the long division. 22 is even, 600 is even, divide the top and the bottom by 2, and that's how we ended up getting 311. So let me know if that makes sense there for you. Oh, for sure, Diego. Yeah, because the math will still check out. You can go ahead and do the 600 divided by 22. More than welcome to do that. Perfectly fine. Yeah. So if that's what you confused you, iPhone, then you're good. You can divide with the 622. No problem. Sweet. So with that, just need to continue with more practice. So yeah, that one wasn't that hard at all. But who here is ready for the next question, where we might have the same scenario, but a different process? Who's ready? Crickets. Wow. I'm kidding. Let's get it. Sounds good. So here you go. Let's try this next one out. Oh, gosh. Oh, no, coach. Save me. Save me. I'm not saving anybody right now. Go ahead and struggle, and I'll see you in a bit. Trust me, you got this. And Eric, to answer your question there, you can get tons more practice. I actually have over 15,000 practice questions with step-by-step solutions in my full program, and you can get that right over here with this link. There's my full program there in the chat box or in the chat, so you can check that out. No problem. And that is time, my party people. How are we feeling about this one? Put those answers in. Put a question mark next to your answer if it's a guess. But you tell me, how do you feel? How do you feel about this one? Get myself back in the frame here. Perfect. So yeah, how do you feel about this one? It was easy. Okay, okay. Feel confused, easy, confused, question mark. Okay, I'm seeing a bunch of mixed reviews. I use the formula y equals mx plus b. Delilah, excellent work. And I'm going to show you how you can still use the distance rate time formula for this one too. So not so sure. I think I did good. I think I did well. Jahida, come on. I think I did well. Let's see. So not so sure, Lynn. Eros, you think you did good. Okay, let's check it out. Let's see where we are with this one. So let's get started here. The tricky part was the rate. Remy, you misread the question. Okay, so this one's definitely up for debate, right? In terms of how easy or how doable this one was in the beginning, but let's go ahead and show you how to get this done. Now, because class is almost coming to an end, I do want to remind you guys how to find more practice just like this. So, quick question, everybody, can you see the screen behind me? Can you see the screen behind me? Perfect. So for those of you in the program, what you see behind me, this is the list of all of the concepts in arithmetic reasoning. So if you look right behind me, you'll see things like proportions, general word problems, unit conversions, but this one's about distance, rate, and time. So when you click right there, that gold that says unit checkpoint, well, that's going to take you here. And this right here, this is amazing, guys, because you're going to have the ability to do timed practice. So not just, hey, take your time, whatever. No, you get to feel the pressure of actually being in front of your recruiter and actually going through these motions. Number two, hey, once you actually go through them, so I'm going to hit ready to start, you're going to see brand new questions every single time. Every single time. And it's going to recycle all the way through. So you're going to have different numbers, different scenarios, and you're going to be able to answer all the different types of distance, rate, time questions that I put forth for you. Number three, the best thing about this is not having the questions and not having a timer, but being able to learn from your mistakes. So when I hit yes, I'm done with this questionnaire, I'm done with this exam, well, guess what? Hit that button that says feedback report, and you have everything you need to grow. I go through every single problem from the easiest of the easiest to the hardest of the questions here. I show you exactly how to get these done step by step. Check it out. Every single one of these has a step-by-step solution all the way through. And so that's what I want to really make sure you see. The ability to understand, hey, what do I want? What do I have? What's the connection for every single one of these problems? I need to be able to see that you guys are able to learn from these mistakes. And this is how I'm going to guarantee it for you. So with that said, guys, again, for those of you in the program, Arithmetic Reasoning, Unit 5, Distance, Rate, Time, try out that unit checkpoint or look at the recorded lessons, the guided practice videos, the extra practice you see in there to make sure that you're tip-top form before moving on. All right? So with that, let's go ahead and go right back here and let's solve this thing. I got you, Ryan. So let's go ahead right over here. So here, focus on the question. How many total gallons of water can the container hold? Okay. How many total gallons of water can the container hold? So if we're checking this out, let's just write that down. We can write blank total gallons. Blank total gallons. Sweet. So everybody, is it fair to say that when we're reading that, just that question by itself, we can imagine that. We can imagine that we have a container and we're trying to see how much water it can fill up with. All right, cool. Sounds good. Sounds good, sounds good, sounds good. Again, we're just trying to imagine this container and we're just trying to see, hey, how much is it at the top? How much total water can it fill with? Nice. So let's look at the information that we're given. What information are we given? Well, what we see here is, hey, a container is being filled with water at a rate of 32 gallons per hour. Oh, everybody, what kind of a unit is that? Can you tell me really quick off the top of your head? What kind of a unit is that? Right, that's a rate. And pop quiz time. What's the key word that gives it away? What's the key word that gives it away? Yeah, the word per. Every single time, that's what gives it away. So the word per gives that right there for us. So we have a rate equals 32 gallons per hour. Okay. Now, what's the next thing that we see? It says, hey, look, with 105 gallons of water already present in the container, it'll take 12 minutes to fill. So again, we see that we're given, let's use, I would say purple for this one. So let me highlight this in purple for you. So with 105 gallons of water already present in the container, we can say that, hey, right here, we can just say, hey, 105 gallons already there. I know it's chicken scratch at the bottom there, but it says 105 gallons are already there. Then right after that, it says it'll take 12 minutes to fill. 12 minutes to fill. All right, my party people. So here's where the magic happens. We need to now make sure that we know what it is we're solving for. Everyone, are we solving for a distance in this question? Are we solving for a distance in this question? Because we're looking for the total gallons. We have a rate. We have a time. Does it seem like we're looking for distance? Brian's like, oh, so here's the thing. Not exactly. We're looking for the total that this container can hold. If we went ahead, everybody, watch this. This is a very common thing that people might do. If we treat this purely as just, again, this is the mistake that people make. D equals R times T and I'm done. Wait up. If I treat it just like that, distance equals rate times time, well, guess what? The distance that I'm going to solve for, allegedly, is the rate, 32, times time, which is 12. And if I went ahead and did that, if I did that with all the carefree, diddly attitude in the world, I'm going to do times 12, 2 times 2 is 4, 3 times 2 is 6. Next line here, 2 times 1 is 2. Then 3 times 1 is 3. I'll add that together, and I'm going to work my way through. Yeah, man, 384. I feel great, man. Look at that. 384 is right there. I'm going to just destroy that right there, and I feel great, man. Frosted Flakes. Am I correct? Right, not correct. You guys are screaming at me in the chat box, right? No, we left out the 105. Everybody, what we just solved for, yes, that is a distance. That was an amount that we were trying to accomplish, but it wasn't the goal of the problem. That was part of the goal, because this right here, this behind my big old head, this 384 gallons, that right there, that's this. That's that. That's the 384 gallons. That's the distance we went that we needed to achieve to get a full container. But what we failed to realize, or may have failed to realize, was that we still had the 105 from here that was already there. And when we add that and get the total, that's actually going to be 489 total. That's 489 total. And notice how the answer was there, though. 384 was right there because I tried to trick you, and I may have succeeded. Did I enjoy that? No comment. Do I want you to get better from this? Absolutely. And so the correct answer is truly going to be A, 489 total gallons. Nope, didn't get you at all. Infinite didn't get you at all. I love the sarcasm. Sweet. So, with that, everybody, are we seeing how distance rate time problems can be more than just pure distance? And also, beyond that, do you also see that you must, and I mean must, take a look at what the question is having you solve for? That way, you can use these formulas not as the end all be all, but the formulas as part of the process to get to the greater solution. We always have to think about it like that because not every problem requires one formula. Like just like I told you guys about, hey, this grand old update that I made to the chatbot that you guys can communicate now through me, that wasn't as simple as writing one function or one script. I had to write many scripts that all communicate. So remember, guys, these questions oftentimes, especially the harder ones, are not going to be reliant on one process. You have to think about the grand scheme have in order to get there. And knowing your formulas is just step one. Kenneth, I'm glad, man. And Delilah, and I'm going to make this comment. So for those of us on YouTube and Zoom here at the same time, Delilah did a very beautiful thing. Delilah says, hey, coach, I can use y equals mx plus b to solve this. You absolutely can, Delilah. Absolutely. Because the b would have been the 105 that was already there. The m and the x are the rate and the time. And the y would have been the grand total, the 489. Absolutely. It's like I've never done math. And so actually, let me see over here. Hey, Bruce, actually, thanks for pointing that out, Bruce. Let me actually write that down. That's a mistake, actually. Thanks for pointing that out. That is an error that I can fill. Cool. I can actually correct that. So let me just star this up. I'm glad you pointed it out. That should be hours. And I will have that fixed and updated in the program first thing tomorrow morning. Appreciate that, Bruce. Yeah, thank you. Thank you for pointing that out. Appreciate you. So it's 7:46. We still have time for at least one more question. You guys tell me. Would you guys like to try out a medium question, or would you guys like to go all the way and try to go for a similar, harder question like this one? All the way? All right. Sounds good. Sounds good. So let me go ahead and find one here. You know what? I like this one. I like this one. Go ahead. I'll give you the 3 minutes on this one. This is another realistic question that you can expect to see. Go ahead, give it a shot. Timer has started. Let's get it going. And just as a little motivation, it's the ASVAB. And looking at our final 3, 2, and 1, my party people. Go ahead, put those answers in. What do we have? Let's go ahead and finish class off the right way. Timer's up and back in. All right, so here we go. First question is this, everybody. Do you feel like so far this has been worth the experience? Seeing these different types of distance very time questions, has this been good for you? You tell me. I see there's a little bit of lag on YouTube there, but no worries. And then back on Zoom. Yeah, right on. Right on. Let's go ahead and tackle this one. And again, every single time, go with the purpose of the question and then see what information fits. So here we go. Right on, Brian. So let's go ahead and tackle this here. The main question here is, hey, how long would it take for the first plane to catch up to the other? Okay, great. I think it's pretty clear. I mean, I don't know what the situation's about yet. I haven't read anything yet other than the question. And it says, how long will it take one plane to catch up to the other? Okay, plane catch up. And everybody, just a big hint. Everyone, if we have this plane and another plane going to catch up to it, what do you notice about the directions of the planes? What do we notice about the directions of the planes? Yeah, they're going in the same direction. They're going in the same direction. So, hey, right there, that might hint that if we have two rates, if allegedly we have two rates, we might actually subtract those rates. I don't know. You tell me. Let's find out. So again, how long would it take for the first plane to catch up to the other? And so we'll go ahead and write out blank hours to catch up. Perfect. And let's read through the information. Let's see what we have. So we have here a plane traveling at a speed of 675 miles per hour is attempting to catch up to another plane 1,200 miles ahead. The other plane is traveling at an average rate of 375 miles per hour. Okay, sounds good. So what that tells me is, again, we have one plane right over here that's already ahead. This one is going at 375 miles per hour. And then there's another plane that's trying to catch up to that one. And that's a broken plane. Let's not draw broken planes here. We don't like that. So we'll go ahead and draw this other plane. That's going again much faster, 5 miles per hour, in an attempt to catch up. So everyone, let's think about it logically speaking, rationally, with our common sense here. If you are trying to catch up to something else and you're going faster than that object or that person or that thing, is it fair to say that eventually you will catch up? If you're going faster than they're going, but you're behind them. But if you're going faster than they're going, eventually, right, you'll catch up. Cool, great. Then you understand the premise of the problem. That's all I'm trying to do. I'm trying to help you visualize that this is a very doable question, because if you can see it, if you can draw it, then you can do it. So here we go. We have the 675 taken care of or taken into account, the 375 taken into account. The only thing we haven't taken into account is the 1,200 mile distance. That's what we're trying to close. So our distance that we're trying to close is 1,200, but the real question is, what is the rate? So we have the 675 and the 375. Everyone, what will we do with those rates? The planes are going in the same direction because one's trying to catch up to the other. One's going faster than the other. What should we do? Yeah, that's right. We have to subtract. We have to subtract because the planes are going in the same direction. Every time that catching up plane crosses the distance that the other plane already went, it's like canceling it out. It's just canceling out. And so the catch-up speed is actually different because we have one going 675, the other is going 375, which means that the true catch-up speed is 300 miles per hour. This is our true rate. This is our catch-up speed. Let me write that down for you right here. Catch-up speed or catch-up rate, just to be a little more formal, but you get what I'm saying. That's the pace at which we're catching up. Boom, that's the true rate. And if we plug that in, you don't even need to do the formula. Everybody, if we're going 300 miles an hour catching up, and we have to catch up a distance of 1,200 miles, what's the time? Yeah, it's going to be 4. If we do D equals RT, I'll just do it for formality's sake. Distance equals rate times time. Well, that's going to be 1,200 equals 300 times time. Divide both sides by 300. I know I'm working diagonally here just because I'm excited. That's going to give us 4 hours. And that's what the time is right here next to my big old head. And we'll see that the answer is A, 4 hours. So how do you guys feel, man? This class, I really enjoyed this class because we were able to get through every type of question that's currently available. And I want to make you guys aware and surprise you guys that there are even more questions coming up in September. Now that I've finished this first iteration or the second iteration of the progress chatbot that's going to be available to you guys right now, next thing for me to do is continue to work on more experiences for you guys who are in the program and for those of you who are curious about it. That means more distance rate time questions are coming up in September and more. We have all these different topics coming in with more scenarios. That way you get the practice that you need, trusting that you'll be able to watch or read step-by-step solutions to continue improving. So right on, Delilah, I love seeing that. It looks like you're next step to passing the ASVAB. I love seeing that. So with that, I do need to hop off soon. So I will leave you guys with a couple of good words here to make sure that we're making progress in the right way. So for those of you who are in the program, it's going to be very, very prudent of you, which is something that is good. You guys should definitely look forward to completing everything in order. Like I said earlier, if you're in the program and you're struggling with distance rate time, struggling with proportion, struggling with whatever topic, there's a reason for that. And it's not just, hey, I'm going to sit here, open a book, and hope what happens works. No, there's a structure to things. So again, if you're in the program, this is the number you want to text to get a real-time, the 833-321-0182. That's the number you want to text to get a real-time updated progress report for yourself. That progress report will include how far you've come. It'll tell you if you've skipped any assignments. That's another feature that's also the reason why I did this to begin with. So that way you don't find yourself in arithmetic reasoning confused on distance rate time problems, but come to find out you skipped half of the math basics. So this progress report, this automated system is so good because it's going to help you understand exactly what it is that you need to do to avoid any confusion and to continue building confidence. So again, if you're in the program, text that right now, asking for a full progress report. And I can guarantee you in a few minutes, it'll give you a progress report of where you currently are, where things stand, if you skipped anything, and encouragement moving forward. Okay? So I love you guys. If you're in the program, that's your goal right there. Continue making progress. Keep killing those speed drills and unit checkpoints. You've got this all the way. And for those of you who, again, are interested in the full program, I would definitely love for you to try out the full program for a week for free because coming soon, starting tomorrow, actually, our Labor Day sale is starting. So if you would like to try the full program for a week for free before you go and try that out, for sure, go ahead. I'm going to put the link in the chat box so you can try the full program out for a full week for free. All you have to do is follow the directions that are on the page there, right over here. Boom. It's a quick little video to watch, like 45 seconds, but all you got to do is fill out a form, confirm your email and phone number, and you're set to go. Full week for free on me. And if you're ready to purchase, then I would highly encourage you to go ahead and use this discount code if you'd like to while we generate the code for the Labor Day sale. Here is the link to the full program. And use the code ASVAB25 if you'd like to save 25% off of any plan. The Labor Day sale might be 20%, not 25%. So, hey, take advantage of the 25% discount there. It's 25% off your first month or 25% off the full year or the lifetime package. If you would like to go ahead and study as long as you'd like to, get the year. If you want to pass as quickly as possible, get the monthly. If you want to pass now and get promoted later, and just have all the resources you need for life, the lifetime is going to be the way to go, especially with that massive discount. So my party people, I love you guys dearly. You guys have been amazing. Thank you guys for being patient with everything going on. We have another class coming up tomorrow, so I'm really looking forward to seeing you there. That class will only be on Zoom, as well as the class on Wednesday with Coach Sheena. But as always, the goal is to avoid that test anxiety, not avoid studying altogether. And so to do that, we have to tackle things the right way, head on, without any remorse for anything else. Do what it is you got to do to make this success happen. I got your back, guys. Coach Anderson. And as always, if you have any questions at all, feel free to text any general questions to 833 right there. I don't know why that's glitching. That's weird. So right there, if you have any general questions, go ahead and shoot me a text at 833-321-0182. Or if you need a human to address your concern or it's a specific issue, then you can feel free to email us at support@duranlearning.com. But I promise you the 833 number should be able to handle all the questions that you have and get started the right way. So with that, my party people, I love y'all. As always, we have our Labor Day sale coming up this week, and it's going to be amazing because we have updated the program and you'll be charged less. So that's awesome. You guys be real or stay amazing. I'll see you in tomorrow's class, and let's keep acing the ASVAB, guys. Cheers.